Hi everyone, welcome back. So for today we have GFG problem of the day. The question is added distance. This is a quite famous recursion DP problem. So what the question is? In the question we are given two strings str1 and str2. We have to return the minimum number of operations required to convert str1 to str2. The possible operations that are permitted are that we can insert a character at any position of the string. We can remove any character from the string, and we can replace any character from the string with any other character. So we shall see the test case. The test case is string 1 is geek, string 2 is cheesec. So the minimum number of operations is 1, as we can insert s at this position, at the third position, and it will be converted. So how shall we do this? First approach that we can think of is using recursion, the basic recursion. And in that recursion approach we can apply DP as we have two strings. We will use two indexes, I index for str1 and j index for str2, and we shall see all the conditions and apply the calls. We have three calls: insert, remove and replace. So moving to the solution part, first of all we have made an integer DP. We have two strings, so we have 2d DP. First is str1 dot length and second is str2 dot length. So we have a 2d DP. Now we have made a recursive call. We have passed first parameter as string 1, second parameter string 2, 0 is the index for I for string 1, and 0 the index j for string 2, and then our DP. At last the answer will be stored at 0, the index 0 index of our DP. So we have returned the answer. So now moving forward to the recursive function. This recursive function will return an integer, that is the minimum number of operations every time for every ith and jth index. So what shall be the base conditions? Moving to the base conditions, the first base condition will be when we reach I is at the str1 dot length and j is at str2 dot length, means both the strings are completed. So when both strings are completely converted, then we do not need any operations, so we shall simply return 0. Second base condition shall be if I reaches to str1 dot length but j does not reach to str2 dot length, means some characters in str2 are left. So we shall have only one type of operation for minimum, and in that case, that is, we shall insert remaining characters in str1. So those operations will be equal to remaining characters of str2. So in this case, we shall return str2 dot length minus j. Other base case shall be if I is not I does not reach to str1 dot length, whereas j reaches to str2 dot length, means string 2 is completed but string 1 has remaining characters. So in that case we have only one operation, that is we have to remove the remaining characters. That will be equal to length of remaining characters in str1. So the other base case is j is equal to str2 dot length. We have to return str1 dot length minus I, that is the remaining characters. So these are the base cases for the recursion. Other condition is if we have pre-computed solution in our DP. We have already computed the minimum number of operations for this index I and jth index. So we shall directly return the answer without computing again. So this is the dynamic programming approach. So if dpij is not equal to null, means we have a pre-computed answer. So we shall directly return the answer from our DP. If all these conditions are not there, then means we have to compute the answer for ith and jth index. So that answer shall be minimum number of operations. So we have kept a variable min. Now one thing we know is if our character matches, if our ith character matches with jth character, then we do not have to do any operation. we do not need to perform any operation, we shall directly move ahead because we want minimum, right? So if character str1 dot caret I matches str2 dot caret j, then minimum number of operations will be next recursive call, I moves ahead, j moves ahead. If this is not there, then we have to apply some operation, that is must. So in else case, we have three operations. So we shall have three calls. First operation is insert a character. If we insert a character anywhere in str1, that means our ith index will remain same, whereas jth index will move ahead because the character we have matched with inserted character. So str1 I remains same, whereas j moves ahead. Second call is remove any character from string. If we remove any character from string 1, that means the index I moves ahead, whereas j remains same because jth character has not been matched, ith character has been removed. So I moves ahead, j remains same. And third call is replace any character with any other character. That means we are matching ith character to the jth character by converting it. So both move ahead in this case. And we have performed one operation. We have performed any one of these three operations. So we are increasing min by 1. So this min has the answer minimum number of operations for the ith index and jth index. So we store the minimum in dp so that if this condition dpij comes again, we do not have to make calls. We shall directly provide the answer to optimize our recursive solution. So this is the simple solution for this recursive DP problem. I hope you guys would have got the idea. This was the simplest solution. Thanks for watching the video. Have a nice day. Thank you.